Hello, this is Team MSR, showcasing our demo to E80's Autonomous Navigation Final Challenge with Manchester Robotics PuzzleBot. Here is the team's PuzzleBot, where capabilities of classical computer vision, closed-loop control systems, and modern neural networks were mixed to achieve the vehicle's exhibited and desired maneuverability.
Starting with line detection. Bird's eye view, BEV, perspective transformation is applied to the camera feed. This eliminates perspective distortion, making the lines appear straight and parallel, which is crucial for accurate measurements. Then, these images are pre-processed using techniques like adaptive thresholding and morphological operations to create clear black and white representations of these lines. Next, the image is divided into three regions of interest, left, middle, and right, to identify the distinct lines on the track. For each region, the largest line contour is detected, and a straight line is fit to it, using the detected lines. A peak controller is implemented. This controller calculates the robot's necessary linear and angular velocities to keep it centered and aligned with the chosen line. For interaction with the signs, several techniques are applied to squeeze the maximum juice out of the Jetson Nano. Image transport is implemented for compressed images, CUDA video memory for efficient image processing, and finally a powerful C++ implementation of YOLO v10 with TensorRT, which makes detections run at more than 100 frames per second, which could lead us to even running this problem directly on the Jetson without problem. The model was also carefully trained and fine-tuned 3 times to achieve peak detection in any situation, fine-graining the settings and augmentation parameters. All this data is fed into a carefully designed finite state machine, which applies careful relevance mapping to feed several of crafted trajectory generators, depending on the situation needed to be navigated. For edge cases like the intersections, curves, or even straight lines, the waypoints are generated using different known key points and some assumptions. For example, by finding the center of 2 dotted lines and assuming both have the same length, a theoretical trajectory to navigate it is plotted and translated as a line of our line follower node. For semaphores, special colored blobs are detected, which in turn become multipliers of the velocity, like yellow being half of it, green being 1 of it, and obviously red being 0 of it. At the end, we end up with this diagram where the specialty is the activating and deactivation of nodes in a dynamic fashion, which leads to all of our nodes being a perfect choreographed dance, which in turn provides the robustness we need for autonomous navigation. Now, let's talk about problems. In general, 2 GB of RAM is way too little for running what we wanted. The fragility of the software we were given led us to lose way too many hours debugging what we shouldn't be debugging.